Let's talk about formulas for area of a kite and a rhombus. So here I've got a figure of a kite drawn. So if we remember back to last semester, a kite has four sides in which two sets of disjoint consecutive sides are congruent, meaning these two sides would be congruent because they're right next to each other, and then these two sides would be congruent because they're right next to each other. If I wanted to find the area of a kite, it is important that I know the lengths of the diagonals. So notice that I have the diagonals drawn into this figure. A couple of things to remember about diagonals of a kite. Remember, the diagonals are perpendicular to each other, forming right angles. And between the two diagonals, the shorter diagonal will always be bisected by the longer one. So hopefully we can kind of, not assume, but it appears in this picture that the shorter diagonal is actually the vertical one. So then these two little pieces there would be congruent. But like I said, it's important that we know what the lengths of the diagonals are. So in this figure, this diagonal from corner to corner, I'm going to call that diagonal 1. And then our diagonal 2 would be this vertical one. And so our formula for area of a kite would be us taking 1/2 the product of these two diagonals. So by multiplying the two diagonals and taking half of that product, we will have the area of our kite. With our rhombus, I actually have two different pictures here because there are two different ways in which we can find the area of a rhombus depending on what information is given to us. A rhombus has four sides. It is very similar to a parallelogram where opposite sides are congruent. The one thing that, because it's very similar to a parallelogram, is that if I am given the height of the rhombus, so remember a height goes from one vertex perpendicular down to the side, so that would be h. The base then would be the side that is dealing with that right angle. We can find the area of our rhombus by just taking the base times the height. If this information was not given to you, another way in which you can find the area of a rhombus is very similar to what I just told you when we found the area for a kite. If I have the diagonals of a rhombus, another quick reminder of what diagonals of a rhombus do. They are perpendicular to each other. They also bisect each other. So if I am dealing with diagonals, I can find the area of this rhombus by doing exactly as what I did with my kite. If I multiply the two diagonals together and take half of that product, I will have the area of that rhombus. Let's look at a couple of examples. If I want to find the area of a kite and I'm giving you the diagonals of 9 and 14, they're giving you everything that we need to plug into our formula. Remember, I want to take 1/2 diagonal 1, so one of the lengths is 9, times diagonal 2, so I'll say the other one then is 14. You can type all of this into your calculator all at once. The one thing I do see here, if I'm not using a calculator, is that 14 is an even number, so I can definitely take half of 14. Half of 14 is 7. And then I can multiply 9 and 7 together. That gets me 63. In this particular problem, they don't give me units, but I do want us to get in the habit of putting units, but our units have to be squared because we are talking about area. So this would be the area of our kite. In this next example, I'm going to plug in the information that's given. So AC, this is 16. Notice that that happens to be the length of one full diagonal, so I'm good there. AD is 17. That is not a diagonal, so we can't use that number in our formula. BC is 10. So what was the point of that? Remember, if I need to find both diagonals, but I only have one of them, Because I have diagonals that are perpendicular, I've got a bunch of right triangles. Remember, the shorter diagonal, in this case, AC, appears to be shorter than BD. That diagonal is being bisected. So if 16 is that length, that means that each of those little pieces have to be 8. And so then notice that we can find this length of BE because we have a family. We have a 3, 4, 5 family. Everything is being multiplied by 2. So notice 8 is 4 times 2, 10 is 5 times 2. So 3 times 2 tells me that BE is a length of 6. I can find this length of ED because if EC is 8, and I know that that's 17. That means this is 17. It's an 8, 15, 17 family. So I can find the length of BD, which is my other diagonal, by adding 6 and 15 together. That will get me my other diagonal. 6 plus 15 is 21. And now I have everything that I need. I want 1/2 diagonal 1, so I'm going to call that 16, times diagonal 2, which we just found to be 21. If you want, you can type all that into your calculator because 16 is an even number. Half of 16 is 8. So 8 times 21 is going to get me that answer. 8 times 21 is 168. Because no units are given, I'm going to just then again say units squared for the rest of that answer. So those are a couple of examples of how you find area of a kite. If I want to find area of a rhombus, 2 different formulas, base times height or 1/2 diagonal 1 times diagonal 2. Because in this first example here, I don't have a height, but I'm giving you the 2 diagonals, we're going to use that formula. I'm going to want to use 1/2 diagonal 1 times diagonal 2. So it says to find the area of the rhombus whose perimeter is 20 and whose longer diagonal is 8. So it appears that this is the longer diagonal, that is 8. Because I am telling you what the perimeter of a rhombus is, remember all 4 sides of a rhombus are congruent. So 20 divided by 4 tells us that each of these sides is going to be 5. That's still not my diagonal, but that's going to be important because the diagonal of XZ is really being bisected. This is 4, this is 4. We've got right angles, so we really have a family. Notice how right off the bat, that doesn't look good. That was a 3, 4, 5 family. So add 3 and 3, and my other diagonal is a length of 6. So plug those numbers that we have for our diagonals. One diagonal was 8. Notice how it said the longer diagonal is 8, which makes sense then that the smaller diagonal is 6. You can plug in all of that into your calculator, or half of 8 is 4. 4 times 6 is going to get us our answer. 4 times 6 is 24. Just like all our other examples, they didn't give us any units, so I'm going to say units squared. And that's my area. Looking at this last example, it says find the area of the rhombus. Notice they're giving us one side to be 25. That could be considered our base, but we still don't have a height in this. They're not giving us a right angle dropped down onto a side. Instead, they've given us one of our diagonals. So it's going to be best if we actually then sketch in our second diagonal because that then creates right angles. It bisects our diagonals. So take half of 48, and that tells us that this piece has to be 24. This piece has to be 24. And then hopefully we recognize that we have a triple. We have a 7, 24, 25 family, and that's going to happen on both sides there. So I have then enough information to use my 1/2 diagonal 1 times diagonal 2 formula. So 1/2, my first diagonal was a length of 48. I want to add 7 and 7 to get my other length of the diagonal to be 14. Plug it all in at once, or you can take half of 48. Half of 48 is 24. And then I just have to multiply 24 and 14 together. And so that gives me 336. Notice in this example, they give me units, they give me feet. So because we were finding area, I would say then feet squared to finish the rest of that.